All right, we've made it to the last video for section 1.5. We're here at the bottom of page 3 of the notes. And at the end of the section, of course, we're here dealing with some application exercises, which is a nice way of saying word problems. And I can't stress enough, we talked about it in the previous video about these foundational translations time. I really encourage you, when you see word problems coming, the worst thing you can do is say, oh, I can't, or I'm never good at word problems. That just physically shuts your brain down to ever getting any better at them, and you'll cause yourself more frustration than you need to. Because one of the biggest tips you can take from this class is realize that the word problems you see are going to relate directly to the section that we're in. So we can expect that this particular word problem is going to have us add positive and negative numbers together, because that's what we've been practicing this entire section, adding positives and negatives together. So let's read it through and see what they give us, and take a deep breath, read it again, and then identify our goal, key information, that kind of thing. Okay, so here we go. Lake Assal in Africa, I hope I'm pronouncing that right, is 512 feet below sea level. What is the elevation of a person standing 642 feet above Lake Assal? Okay, deep breath. Let's read that again and see if we can notice some things. Lake Assal in Africa is 512 feet below sea level. What is the elevation of a person standing 642 feet above Lake Assal? So I am going to highlight here that the lake is 512 feet below sea level. Sea level is considered a 0, above is positive, below that are negative. So I'm going to write this as negative 512 feet. So I've got a lake that's at negative 512 feet. Then I have a person who is standing 642 feet above Lake Assal. So it's real important that you understand the wording and catch what they're describing here. The person's not standing at positive 642 feet above sea level. The person is standing 642 feet above the lake. The question is, the goal we're trying to reach here is, what is the elevation of the person? Okay, which means we're trying to figure out how many feet above sea level they actually are. Okay, they're not 642 feet above sea level, they're 642 feet above the lake. Okay, now I'm a very visual person, so once I've identified my goal and the key pieces of information that they give us here, and keeping in mind what type of problem I'm probably going to do because of the section we're in, I'm going to do what I tend to rely on. I'm not an artist, but I draw a picture anytime I can. It helps me organize all these words into a picture that maybe my mind can see what I need to do next. So here I've got sea level at 0. I've got this lake here, Lake Assal. And this one is at negative 512 feet below sea level. And then I've got this person standing here, and what they tell me is that from the person to the level of the lake is equal to 642 feet. Okay. So the situation I've got here is that if you start at the lake and you add how far from the lake the person is, that will determine this little chunk right here. This is what we want to know. I guess I'll use purple for my goal here. We want to know this amount right here. We want to know if you take negative 512 and you go up 402 feet, 642 feet, you add 642 feet, that's going to give us our goal. Okay? Our goal here is going to be found by taking the level of the lake, negative 512, and adding how far away that person is, a positive 642 feet above that. The above makes us realize we're at a positive 642 feet compared to the lake. Not 642 feet above sea level, just 642 feet above the lake itself. So there, with a little picture, a little bit of some reading carefully what the words are saying here, I have set up what I expected, adding positive and negative numbers together. In fact, I've got a negative plus a positive. So those signs are different. which leads me to remember, oh yeah, I find the difference when the signs are different, which means I'm subtracting. So I'm going to take the 642 minus the 512. That gives me an answer of 30. I always keep the bigger sign. The sign in 642, 512, 642 is a bigger number. I'm going to keep that sign positive 30. And what I've discovered here is that, I'm sorry, not 30, 130. Whoops, 642 minus 512 is 130. So the person is at an elevation of positive 130 feet, which is a way of saying 130 feet above sea level. Okay. And you'll see several like that in the application exercises. So use that expectation of the word problem to match the section we're in. Every once in a while we'll dive into some of these problems that are near the end of each section, and they're under a title, Critical Thinking Exercises. It's really a chance for you to investigate more about this topic and build those critical thinking skills. That's a life skill, right? If you never use the math of the algebra in your career, whatever, definitely everybody in life needs critical thinking skills. So this one asks you if it's true or false, and if it's false, change the statement to make it true. It's almost like you're translating a little bit here, because they're going to give you a paragraph describing a math situation, and you have to decide if that math situation is always going to be true, or is there a situation where it could be false. And if it's false, change the statement to make it true. So here's what we've got. If one number is positive and the other is negative, then the absolute value of their sum equals the sum of their absolute values. At first read, there's just words all over the page. Let's take a deep breath. Okay, if one number is positive and the other is negative, then the absolute value of their sum equals the sum of their absolute values. Let's just break this apart piece by piece. Here's an if statement, here's the then. Okay, so if this happens, then this will happen. We have to decide if that's a true or false. So the first, one number is positive, other number is negative. Okay, so we have a positive number and we have a negative number. Okay, that's what we're starting with. Then the absolute, so this is our if. We're starting with this assumption. Here's our then situation. The absolute value of their sum equals the sum of their absolute values. So let's translate this. The absolute value of their sum, the absolute value of when you add them together. So the absolute value of when you add this positive and negative together equals the sum of their absolute values, adding their absolute values together. We're going to add their absolute values together. Add the absolute value of the positive, add the absolute value of the negative. Okay? So we want to know, is this always true, or would there be a situation where this is false? So sometimes you have to come up with some number examples to convince yourself. You can either think it through logically, or come up with an example where it won't work, and then you'll know that it's false. You can't really prove something's true using number examples, but you can prove something's false by coming up with a number example where it makes it untrue. Okay, so I would suggest that you try numbers to make it false, to try to make it false. I would avoid using numbers like 0, 1, and 2. They have a way of causing things to be true when they're not really true. Simply for things like 0, when you add it to something, it doesn't change anything. When you multiply it by something, it goes away. In this case, absolute value, there's no distance from 0, so that's not going to tell us much. 1 has if you multiply by 1, it doesn't change anything. So avoid using 1s when you're trying some numbers to see what happens. I'd also avoid using 2. Because 2 times 2 is 4, 2 plus 2 is 4. That can be misleading. So I would start with 3 and above, okay? So let's just pick a couple numbers, one positive, one negative. So we're going to try -5 and a -3. So there's our positive, there's our negative. We're just going to try those two numbers. I just kind of pulled them out of a hat here. So positive and negative, we're going to add them together. Oh, I should have put a plus here because they said the absolute value of their sum. Positive plus the negative. Okay, so positive plus the negative. So there's 5 plus a negative 3. Does that equal the absolute value of the 5 plus the absolute value of the negative 3? So now we're testing our numbers that we're trying here. So 5 plus a negative 3, different signs, subtract. 5 minus 3 is 2. Keep the bigger sign, which is positive. So this becomes, this left side becomes absolute value of 2, which is just going to be 2, right? On the right side, you get absolute value of 5, which is 5. And absolute value of negative 3, which is 3. Absolute values make things positive. So on the right side, you get 5 plus 3, which is 8. But 2 doesn't equal 8. So our first test showed that our first test didn't work, and it has to work with all numbers for the statement to be true. So this statement is now false. And then the second part of the question said, if it is false, change it to make it true. So how could we change the original statement so that it would always be true? Well, you can mess around with this for a little while, and I was short on page space, so I deliberately chose what I knew would end up being false. But the way I came up with those was I tried lots of pairs of numbered. I tried the bigger number being the negative one, like negative 5 and 3, and those kind of things. And so what I discovered in all my different tries is that when one is positive and one is negative, it's never going to work because you get a different value here because one of them is negative, as opposed to after you take the absolute values, you end up with both positives. So the only way you could match a both positive situation is if you start with both positives. So to make it true, the change would be that both numbers have to be positive. Okay, so that would be the change. All right, and then another critical thinking exercise here. The description says use the number line to determine if the answer here is positive or negative. And we're looking at adding b plus c. And our picture tells us that with a 0 reference here, some of my number line got cut off here. We've got A way down here, we've got B kind of close to 0, and C kind of a medium distance away here. We want to know, will B plus C be positive or negative? So we get to use some thinking exercise here. We don't know the value of B, we don't know the value of C. We just know that B is a little bit away from 0 and it's negative. We also know from the picture that C is a little bit farther away from 0, it has a bigger distance, and this is going to be positive because it's on the right. Okay. So when we add these two together, we're adding a negative plus a positive. Even though we don't know the numbers that we're adding, we can still think through the rules that we would apply. If we did negative plus a positive, we would be subtracting these two numbers, and then we would get an answer after subtracting them. And then we'd have to decide which sign to use. And we keep the sign of the bigger number. And the picture tells us, even though we don't know values, the picture tells us that this positive value over here is further away from 0. So this one is the bigger sign here. So we're going to, our answer would end up being positive. So we can talk through the steps, and even though we don't know the numbers, the steps will help us get to what this answer should be. So the result of B plus C will be positive. Okay, so that's some critical thinking. This is at the end of all the practice sets you've done. So hopefully you've built some thinking skills along the way because you've pushed yourself through all these practice problems. The point being here, I wanted to pull a couple out and do them with you so that it wouldn't throw you off too much. You'd have an example to kind of rely on when you got to that spot in the practice sets. Okay, expect it to stretch your brain, expect it to grow a little bit, and you'll be a better mathematician, better thinker for it. Okay, that is the end of 1.5. We'll see you for the next round in 1.6.